Hi folks, today I wanted to show you a setup that I use for a water wheel activity that I do with my physical science classes. And this activity can be adapted to talk about forces in motion, work, and power and energy, and all sorts of neat little things you can do with this. But at the heart of it, students will construct their own water wheel, and they're going to be using some high-powered water from our sinks in order to lift some masses to the ceiling. So here's the setup I use. First of all, you're going to need an ample supply of 2-liter soda bottles. I'm going to start by drilling a 1/8 inch hole behind the collar on the bottle, right here on the neck, and it's going to look like this. In the base of the bottle, right in the center, I'm going to be drilling a 3/8 inch hole in order to put a metal rod through it. Make sure that you strip the label off the bottle, because when we start gluing things, it's not going to stick very well to the label, and the label usually peels off. I just use high temp hot glue, because it's about 50 times cheaper than some high-grade plastic epoxy. And done. This is the experimental one that I created, and I've just simply glued some medicine cups onto the side of my bottle. Luckily, my students are much more savvy with a hot glue gun than I am, and made this out of Play-Doh cups. And here's the setup. You can see that we have our bottle mounted onto a metal rod that is then supported. As this is turned by the pressure of the water, it's going to hoist up this 1 kilogram mass. Let's look at each of these parts in much more detail. Here you can see the string, which I have looped through the hole that I drilled and out the mouth of the bottle and tied it off. The metal rod that runs through the bottle is clamped at the front and back. I usually support the mass above the bottle so that it's not hitting it on the way up. And I have a pulley mounted to the ceiling. I position the bottle so that it will be right underneath the stream of water. I also place some masses on the bases of the stands so that way it doesn't fall into the sink. Lastly, and I cannot stress this enough, you should use some type of protective screen to catch the water, because this is a very messy activity, and throwing water 30 feet is not uncommon with this water wheel. When I do this for my students, I usually put a safety screen on top to catch the water and make sure it doesn't spray the ceiling, but I'm going to have this removed for most of the recording. Now it's time to start the fine-tuning. I have a stream of water, and there is tension on the string. As I turn it on, you may notice that the bottle is walking to the left side. That's because of the tension coming from the string. So in order to keep this from happening, I'm going to have to place a clamp at the back of this. And I'm going to improvise here. This is not the clamp I would usually use for such a situation, but in a pinch it'll work. After a few more checks to make sure that everything is in working order, I think we're ready to give this a try. Now this experiment is rather fun, but I do have one piece of advice for you. When the mass comes down, do not try to hold on to the rope with your bare hands to slow it down, or else you'll gain a very powerful and painful reminder that friction exists.
Ow!